Good morning, guys. I think it's past the trolley. Good afternoon, guys. And it's going to be the last presentation before lunch, so bear with me for another 20 minutes. My name is Brian. I'm a lecturer from the University of Canterbury. It's Christchurch-based in the South Island. And I graduated from here, University of Auckland. So for those of you who come overseas university, welcome to New Zealand. And hope you enjoy your stay here. Today my topic is a view of applications of computer visions to construction health and safety. I'm not going to claim that I'm the expert in computer vision, but I've been doing research on construction health and safety since my PhD. So when I read some papers from, for example, the machine construction, it motivated me to reflect the application of the computer visions to health and safety and try to get some insights for future research direction. This paper is co-authored by with Zhou Yang, and the lecturer of the University of Auckland, and Chen Long, who is now here today. So the overview today is a liberal background, research aims and methods, and review results, and more importantly, focusing on the development framework and challenges in future research. You see, when you see the whole history of the health and safety, not only in construction industry but other industries, you see two different research lines. Okay, the top lines represent the safety science research line. During the 1930s, we see the first very classic accident causation model, which is dominant theories, and over time we see different models. For example, Swiss cheese model, and then this model actually try to explain why accident happen and how we can design different accident prevention strategies. But since 2000, we see more and more research and even researchers doing research on safety technologies using different types of information technology, machine learning, computer vision, real-time action tracking, etc. Try to develop different products to help to reduce accidents and fatalities on site. But from what I see, there's a limited interaction between these two lines, and we see different researchers at different lines, and I think for me, probably towards the theoretical side, but I think it's quite important just to think about the interaction between the safety science and the technologies, and how technology they play the different roles in accident prevention strategy. So when you look at human behavior, the reason is that human behavior is a central part of the accidents, even health and safety. So you see different science, for example, psychology, behavior science, social science, and even organizational science. They understand the human behavior in terms of the effects and the causations. At the same time, we see the other disciplines such as computer vision, machine learning, and AI. They try to understand the human behavior because they try to develop some machines that can behave just like humans, just like experts, that we can reduce some human loads, that we can improve the productivity, right? And today we just focus on safety behavior. So this is kind of a dialogue, conversation between safety science and computer vision. And so we can share some insights and see if we can collaborate with each other to develop some better products. So, okay, today the aims is we understand where we are in terms of the computer vision applications. We investigate the camera applications, and then we try to understand the roles of computer vision in accident prevention. The reason is that we don't just sell the products. You publish a paper and you present the products to the industry, say, hey, we use the computer vision, but they ask, can they help us to prevent the accidents? If the answer is no, it's useless, right? So, and then where we should go next? We discuss some challenges, and I tried my best to recommend some research directions and see, the future. The methods is quite traditional. I use a process that consists of literature research, and selection, and coding. I focus just 3 academic databases: ScienceDirect, Taylor, Francis, and ASCE. And at the end of the process, I identified the 67 papers, just focusing on the computer vision or health and safety. And many of the others focus on the structural assessments and some other areas, which is not the scope of research. And if you look at the overview, that we can see an increased trend. Right? Over time, we see more and more publications in this area, and which is very good. And I think they promote transfer the whole industry to the digital, age. If you look at the geographic distributions and see, the USA, China, Germany, and Korea, they're the major countries that lead in the research. But of course, some other countries as well. And this is just some basic results from the literature review, which is a little bit boring, but the focus today is a direct framework. I try to structure all the publications in different levels and see where they are, where they belong. And as you can see, from my perspective, there are 3 different levels of the computer vision for health and safety. The first level is recognitions and tracking. And I think here I noticed there are many experts in computer vision. Some of them already show some demos and great research. And the second level is assessment. We try to understand the level 1 is we focus on, for example, the object recognition, object tracking, and the action recognition. We ask questions, for example, what is the object, right? Is it worker, equipment, or building? And where is the object? And what is the object doing? And the second level is focusing on assessment. We try to understand is the object a hazard, right? And is the action unsafe or safe? We try to get richer information from the computer vision. And then we try to focus on how site is the working condition or scenario safe or unsafe. And I think the last level is prediction, which is quite close to the proactive safety management. We try to get some leading indicators of the accidents, so that we can do something to prevent the accident from happening. So we can predict the behavior and how will the object behave, and incident prediction when the next accident happen. And we try to get some early warnings from the next incident. We do something timely to prevent the accident from happening. So this is a kind of a development framework I think should be useful for the future research. And then at the end of the process, I put all the publications to the appropriate level. For the level 1, recognition and tracking, as you can see, this is a table showing that the current applications researchers in terms of the recognition tracking objects. As you can see now, we can recognize and track concrete columns, trucks, power crane, workers, safety harness, buildings, and hard hats, right? Some of them already show the works. In terms of action recognitions, there's 6 levels of human behavior in terms of the complexity. The most simple one is the gesture. Sometimes we try to understand if the gesture is healthy or unhealthy, or safe or unsafe. The upper level is automatic actions, and then the human-object, human-to-human interactions. As you know, that the construction site is quite busy, and there are many people working on site, and some groups working together, and there's some group dynamics between the group. And of course, you have to understand the group actions and the behaviors. Behaviors is different. We try to understand the psychological state of the workers or the manager, for example. If the safety attitude is positive or not, if the situational awareness is good or not. And the events is pretty much a large scale of the scope. I mean, try to get an overview of the different actions together. As you can see, when I try to put all the applications and try to understand the level they belong to, as you can see from the table here, and most of them are just focusing on the gestures and automatic actions. Okay, and no studies have been done focusing on the human-object, human-to-human interactions, and the group actions, behaviors, and events. So, from my point of view, computer vision to health safety is pretty much at the early stages, and we have a long way to go that they can be really implemented on site. the reason, I'll tell you why. Maybe I'll give you some examples of why that we need further developments. Level 2 is about assessment. For example, you use a computer vision, you use a camera to collect a 2D or 3D image or video streams, and then put the data into the reasoning engine. Of course, we integrate the knowledge model, and if then rules, and then we get the assessment results, if the action is safe or unsafe, if the condition is unsafe or safe, right? And what the hazard control we should implement on site. And we identified 2 major studies that focus on this area. For example, Qing and Cardos a number of years ago, they using data from the level 1 object recognition tracking, and they designed some safety rules to detect different types of the violation. For example, speed limit, dangerous access, and the proximity violations. So as you can see, it's not just about the recognize something or track something. The data is processed using a reasoning engine and get some rich information. And the same, similar, Kim, 3 years ago, they developed a model which has a VPN and SM, and then collect data about special data from the works equipment, and then analyze the data using the fuzzy inference and the if-then rules. So, which is very interesting because we get the rich information and more useful information from the computer vision. Prediction. Unfortunately, I haven't found any study that use computer vision for prediction of the behavior events in the construction industry, but I found some interesting study, for example, from the MIT and in the computer vision community. They try to understand, predict the human behavior using computer vision. For example, they collect some data, the video clip at the very beginning of the action, and try to predict if these 2 people will handshake and shake a hand and give a hug, for example. Okay, they use machine learning, they collect a large amount of data, and I think it may be used in construction industry for health safety, but I don't know, and I think we need more research on level 1 and level 2, and before we go to level 3. Ask us very important questions that before we develop some computer vision based technologies, we really need to ask a question: how the products or the system help the industry to prevent accidents? Okay, so that's why I try to link the computer vision to very traditional theoretical safety research traditions, which are the safety management system, safety culture, and the high reliability organizations, and the accident investigation and models. Try to understand that what's the link between the 2 sides. I'm very happy to see that there's a close connection between computer vision with the SMS and the safety culture and the HRO. For example, I think computer vision can be used in the safety management system in terms of the auditing inspections. For example, in the future, you just install a camera on site, and you can collect data and using some reasoning engine, and you can automatically identify all the hazards, and you can identify the risk level of the whole project over time, which is very useful. In terms of the human behavior and the safety culture, there's a very close connection between behavior-based safety and the computer vision, since they focus on human behavior, but they have a different focus, and I'll explain more later. Another connection is the tension between the belief, norms, and values as the common elements of the safety culture and the technologies. Now, we don't know yet how the technology will impact the safety culture and how the people perceive the safety technologies, and what the negative or positive impacts of these products on the human attitudes and safety culture. And high reliability organizations, the connection point, I think, is a situational awareness. And Yihai just mentioned in the Korean study, I think the technology can help the operator to improve the situational awareness. That can they can understand, sense more about their surroundings, and then help them to make better decisions. And proactive safety management is another area, but this function is pretty much focused on level 3 because it requires the prediction of the future behavior and the accidents. Accident investigation models, there is no obvious link, but which is not important because accident investigation models try to learn from the accidents, then and see how to prevent the future accidents. In terms of challenges in the future research, there are different challenges. Of course, the technical challenges and the theoretical challenges. And you can download some research paper from Automation in Construction, which focus on the technical challenges. Okay, but today I just try to focus on the theoretical challenges in terms of the safety behavior recognition and hazard recognition assessment. In traditional behavior-based safety programs, I think it's less interest to record only simple gestures and some simple actions like not very hard heads and abnormal lighting climbing and unhealthy posture. They're very important. They're very early stage of the computer vision applications. But in one study I did in Singapore a couple of years ago, we actually record some behavior on site, which, as you can see, one of them is the single man gives a warning signal when the load is left or moved, and no one is standing under the suspended loads. Just imagine that you try to use the computer vision and you get some algorithms and use machine learning, and the system must not only identify the single man, the load, the crane, and you have to understand the interaction between these elements simultaneously, right? You need a more powerful algorithm or even a knowledge from the safety to understand the dynamics between different elements, which is not possible now based on the current status, current applications. But if you just detect that if the worker is wearing the hard hats, it's important, but it's not that necessary for the behavior-based safety programs. So we have to ask some very important theoretical questions, which are, what are the criteria or knowledge model that determine if the action, behavior, or event is safe or not? For a very simple scenario, we can use common sense knowledge to get the answer. For example, if you don't wear PPE on site, of course it's not safe, it's dangerous. But for some complex scenarios that involves crane and the truck, and some dynamics on site, it's not that easy to get the reliable answer. And how can we categorize the safety behavior, right? And current application is a little bit fragmented on the research this area. And we need a coherent framework to categorize the different safety behavior that we can better guide the future research directions. And what is the relationship between the criteria and the safety behavior category? So if you change the criteria, maybe you need a different category, right? So if you think about these theoretical questions. Second challenge is hazard recognition. In the far future, if you design some computer vision-based products focused on the hazard recognition, and we expect that they can identify all hazards, right? If they can't, which means we rely on that they can provide the full picture of the hazards. If they can't, I think it's very dangerous because there are many hazards where we may identify, and they will cause significant hazards for harm for the workers. So I just download a picture from Google. I just try to demonstrate that. For example, if you try to understand this construction activity, which is roofing, and you install some cameras and you get data. For example, identify the workers and they get on the roof, and you get data and you get the machine learning and the algorithms. You can track them, you can identify them, and can you understand? Can the system understand the whole scene? Okay, but this is just a small picture of the whole construction site. If you monitor the whole site, can you understand the total construction site? Which is a very interesting topic in the computer vision research community. They call it total scene understanding. Okay, they understand the set of scenes, and we try to create some products that can generate comprehensive hazard recognition system, not just a single hazard. And a sim actually is a view of the real world environments with multiple objects and surfaces in a meaningful way. And the system can not only identify the single hazards, single objects, and but also understand the connection between the elements and understand dynamics and the location and the temporal relationship and the topology relationship. So I believe this is a future, this is a current challenge and the future research directions that we should work together. I think as 3 different research communities, computer science, and the experts in computer visions, and then research in the safety science. I think we can work together and approach this end.
Okay, thank you very much.
Thank you.